Hello and welcome back to our channel. In the previous video, you saw how to design a voice assistant that can conduct a truly dynamic dialogue thanks to Alan AI and real-time database. In this video, we will go on and demo how Alan AI works with a yet more popular database provided by Google, Cloud Firestore. As well as real-time database, Firestore is cloud-hosted. While the first one stores all information in one large JSON tree, Firestore presents all your data as a collection of documents. Let's dive deeper into it. We will assume that in our database we have a collection of products that we offer through our app. Each product or a document in our collection has a unique ID and three fields: name, price, and description. We will start with querying information from the database. Let's say we want our users to be able to retrieve a list of products above or below a specific price. All the operations that we are planning to perform will be carried out over the REST API. Let's open the Firestore documentation and see how to query data from our collection with the help of REST requests. As the documentation suggests, to run a query, we need to send a POST request to an endpoint and add the run query parameter to it. So we will start with adding the endpoint URL to the voice script in Alan Studio. In the body of the request, we need to provide the structured query object. Firestore will use this object to run a query on our collection and return all the data we need. So, step 2 is to construct the object. We will define the name of the collection to fetch the data from and the fields filter. Here we will create a really simple query to get a list of products whose price is equal or less than the value specified in the price field in our documents. The object is ready. Now we will add a function to use it. We will name our function fetchData and use Axios to send a POST request to our database. Here we will pass the endpoint URL and the structured query object as parameters. When we get the result, which will be a set of products that match the query conditions, we will save the name and price for each product to variables and log them. And in case of an error, we want to log it as well. Let us call our function and check Alan Studio logs. Next, we can add an intent: show me products that cost around a specific price and below. Here we will use the number predefined slot to capture the price and pass this value to our fetchData function. In the function itself, we will assign the price value to the corresponding field of the structured query object and play the list of products we get along with the prices. We will test it. Some improvements here. First, let our voice assistant name the prices in the currency format. And we can also change our function and intent to accept different conditions: equal or less and equal or greater. For this, we will add a regular slot, name it filter, and allow our users to choose whether they want to go up or down the defined threshold. We will pass the value captured with the slot to our function. In the function, we will add a switch case to define which operator to use in the query. And finally, we will save the necessary value in the operator fields in our object. Let us try our intent with different price values and conditions. Show me products that cost around $75 and above.
Apple EarPods is $78.98. Samsung Galaxy Buds Live is $99.99. Beats Studio Buds is $135.45.
Show me products that cost around 100 and below.
Sony WFC 500 Truly Wireless is $68.55. Apple EarPods is $78.98. Samsung Galaxy Buds Live is $99.99.
Let's move on to the second case and let our users get the info about the product they are interested in. For that, we need to add an intent like, tell me about some product name. To pick out the product name from the user's phrase, we will use a slot in the pattern, just like the filter slot we used to get the filtering conditions. The tricky part here is that we want our slot to be adapting. We already have the names for our products in the database, and we do not really want to maintain a similar product list in the voice script as well. If something changes, for example, a new product is added to the database or some product name is altered, we want our voice assistant to get these updates immediately. To meet this challenge, instead of a regular slot, we will use a dynamic one. Let's see how we can retrieve the names from our database and use them in a slot. We will add the getNames function to our voice script. When this function is called, we will first create an empty list. Then we will send the getRequest to our database, get a response, and push the name for each document to the list. Then we will join the list using the vertical bar delimiter and save the result to the p_userdata_item_list variable. Next, we will call our function when a new user starts the dialog with our voice assistant and check what we get. Let us create the Tell Me About intent. Here we have a dynamic slot. The uLetter denotes that we need to get the data for the slot from the userData object. When this intent is matched, we want to play the item description to the user. So let's add the getDescription function and pass the name captured with the slot to it. In our function, we will reuse our structured query object and do pretty much the same we did before when we got the products list. But this time, we want to get the product whose name is equal to the value of our dynamic slot. We will send a post request, pass the endpoint URL and the query object to it, and then play the product description. Let us check it in the debugging chat. Well, this works if we type the exact value that we have in the database. But if we say, tell me about Apple EarPods, the request will be sent in the lowercase, and we won't be able to get the description from the database. To fix this, we will add a label to each value in our slot. The value field of the slot captures your input, while the label contains the exact value you define. And we will update our function to pass the label, not the value to it. There is still some room for improvement. As we can see, our product names are compound, and some of them contain digit and letter combinations that our users are likely to skip when naming the products. Let us add tilde to the slot name to make it fuzzy. This way, Alan will be able to match our intent even if the product name is close but not totally equal to the one we have in our database. The true power of dynamic slots is that you do not need to make any edits to your script when your database changes. For example, we will add a new product to our database, start a new dialog, and ask about this product. Tell me about Bose Sport earbuds.
Bose Sport earbuds are designed from the ground up to energize your exercise with acclaimed lifelike sound and a comfortable, secure fit. Proprietary technologies make your music sound clear and balanced, no matter how loud you turn it up, while the earbud's sleek design allows them to sit close to your ears.
As you can see, our voice assistant gets the latest changes from the database on the fly, and you do not need to update your voice script. And the final use case, let us see how to write data to the database with voice. We will assume that we want to capture users' comments about the app and store them in the comments collection. We will add the write data function here that will send a post request to our database and store the comment to the comment field. Now, we can add an intent to capture the comment with a regex slot and call our function. We will test it and let us see how authenticated requests work with Cloud Firestore. Say, only authorized users should be able to leave comments about our app. This works in the same manner as with the real-time database. In your app, you need to get a token for the authenticated user and pass it to the voice script with the help of Alan's auth data object. Once this is done, you can pass this token as a header parameter in the post request. You can find a link to the video on authenticated requests in the description section for this tutorial. Alan AI is a developer-friendly platform that lets you work with any data sources to build flexible, adapting, and dynamic dialogues. Try it yourself, subscribe to our channel, and comment on what you would like to see next.